Hi, my name is Bryan Stiekes, and I'm a technical director in the Office of the CTO here at Google Cloud. I'd like to spend some time today talking about the innovation and technology that has allowed Google to grow over the last 20 years and how that might be applied to geospatial analysis. Google's mission is to organize the world's information and make it universally accessible and useful. When you think of Google, this is probably what you think of first. When I think of Google, I tend to think of the infrastructure, the data centers, and the technology that sits behind giving you a very quick, high-quality answer to that question that you may have asked. Like most, Google started pretty small. This is a purchase order for the first 3 racks that we acquired. Along the way, we learned an awful lot. We learned an awful lot about how to build hardware. We learned an awful lot about how to build distributed systems. And we learned a lot about how to operate platforms and applications that are serving billions of users every day. Some of those things that we've learned are to be more data-driven and to build the tools necessary to be more data-driven. We learned to be more collaborative and productive. We learned to deal with a lot of security threats, and we learned to be more agile. The great thing about Google Cloud Platform is that this is the way that Google is making these innovations, these technologies, and those solutions available to you to solve the problems that matter the most to you. Some of those approaches are first, building the foundations for cloud-native systems and services. Second, providing a serverless data platform. Third, letting developers just code, freeing our organizations from the difficulty and pain and cost of managing the infrastructure necessary to actually deliver value from the organization. So let's talk first about that secure foundation. This is kind of historically the view of security within IT. We try to build ever stronger walls. We try to build ever more complex systems, all with the goal of protecting the things, the assets, the data, the systems that matter most to us. The problem is that everybody's a target of cyber attacks. And increasingly, it's a question of when, not if, you're going to be breached. The cost of those attacks is enormous. Google takes a little bit different view of security. That is, first and foremost, trust nothing. Build systems that are secure. Take a look at everything from the very bottom of the stack in the hardware, through the software stack that runs on top of it, the network that connects it, the applications and services that run within it, and then the operations and people that guarantee that it's available. That really is reflected strongly in our hardware infrastructure. First and foremost, going down to building custom silicon that allows us to establish root of trust in our systems, up to purpose-built servers that don't have components that we don't require, and that may introduce fragility or security vulnerabilities into the environment. Purpose-built storage, purpose-built data centers, and a purpose-built network to connect all of it. Let's talk briefly about that purpose-built network. Google's network spans and connects all of those data centers together. It makes it possible for us to execute queries from one data center to another. It makes it possible for us to execute massive data uploads and massive data transfers. It makes it possible for us to transmit and ingest huge amounts of data from our customers and on behalf of our customers for their own analytic events. That network stretches across the globe, and we're pretty proud to say that we even go so far as deploying our own fiber across the oceans in order to connect continent to continent. It's grown over 20 years to the point that it carries, by external estimates, more than 25% of the world's internet traffic. That infrastructure is what enables our customers to serve over 1 billion end users every day off of Google Cloud. This is one of my favorite examples of the result of that innovation that's been built up over the last 20 years. This is a couple of years old, but it's an example of a professor at MIT who was doing some mathematical calculation that required an enormous amount of computer processing. His record is now approaching over 600,000 cores that he was able to acquire. And what's interesting about this is that he was able to spend and consume nearly 300 core years of compute time. for a mere $20,000. Because of the ability of the platform to scale that workload out broad and wide to the point that it was able to process it quickly, get the answers that he needed back quickly, and do that over an enormous amount of compute capacity that he would not have been able to acquire if he'd had to do so traditionally. So that infrastructure is laying the foundations for cloud-native services that can scale and deliver responses and answers faster than ever before. Let's talk a little bit about a serverless data platform. If you think about Google over the 20 years and getting to that attitude where we need to be more data-driven, we also had to build the tools that would allow us to do that. And you can see the innovation here in MapReduce and Bigtable that we developed inside of Google to get a handle on our own data and get answers back, and that were then open sourced and built and kind of transformed the world around us in Hadoop and HBase. We've carried that further, though, because we want to take a look at the typical data and analytics lifecycle. First, you have to specify the hardware. You have to acquire and provision that hardware. That itself can be a never-ending loop between yourselves and the CIO. Then you actually get to coding and development, logging and monitoring, and then the maintenance that has to go on in order to manage and tune that environment. And what we see in a life cycle like this is an enormous amount of effort, time, and cost that is spent on services and components that aren't actually delivering the value. The value is coding and development that's getting us the answer. So the approach that we've taken is to instead look at a serverless platform. Just send events, just write pipelines, just run the queries. Don't spend all of your time as an organization managing the infrastructure, securing the infrastructure, and constantly having to go back for additional storage capacity or additional query capacity. One of my favorite examples here is from a customer. There's a link here that you can actually go in and view a video from one of their presentations at Google Cloud Next. But I like to see it in their own words. BigQuery allowed them to transform their data estate because first, it was incredibly fast. Finally, it gave them no more infrastructure that they had to manage. But the one that's my favorite, it's just SQL. It meant that they didn't have to train or retrain existing engineers and analysts that were using SQL, but because SQL is so basic, so fundamental, it allowed anybody in the organization to take advantage of that data analytics platform. So not only did it allow them to scale their analytics out broadly across the organization and get answers faster, but it allowed anybody in the organization to just sit down with SQL and perform a query. One of the other examples that I love of democratization of Google's innovation is what we've done with machine learning. You really have an option at Google. You can use our models or you can train your own. We've got a platform that allows you to start at the very bottom where you see the storage infrastructure and custom hardware that allows us to run these models, these inferences, and train them faster and faster because of the custom hardware that we've built. We've also got a platform of libraries and tools that allow you to build your own models or allow you to even build additional frameworks, or you can leverage those building blocks that we've provided. Why is this powerful? Well, this is powerful because very few, if you look across the market, very few can actually use or extend these open source software development kits and AI machine learning frameworks. More can build and customize models. They can bring their data onto the platform and they can take advantage of things like AutoML and the accelerated TPUs in order to build or train their own models. But anyone can take advantage of the APIs that are available on the platform in order to transform their own workloads or in order to bring new insights. The final attitude that we've got is to just let developers code. Don't make them spend all of the time first finding their infrastructure platform, building operating system configurations, having to orchestrate the containers of their applications, storage and networking. Instead, just go to a model that doesn't require provisioning, that allows you to only pay for what you need, and doesn't require you to manage servers. Just write code, run it when you need it, and shut it down. So what? Why have I spent all of this time talking about the infrastructure innovations that Google has brought together. Well, because putting it all together allows us to democratize geospatial on Google Cloud. The vision. We want to release geospatial workloads from legacy constraints with an exabyte scale geospatial data lake driven by Google Cloud Services and Maps data. What does this look like? Well, this looks like a series of capabilities on Google Cloud that allow you to process tabular or image data and existing data assets in the environment that allow you to enrich your own data or potentially go get the insights that you already need. So let's talk about that tabular data real quick. What we've done is we've extended BigQuery with geospatial support. So now you have that power of that cloud native analytics platform that still uses good old-fashioned SQL and is being extended with new verbs to be able to allow you to extend into GIS data so that you can take the power of that scalable analytics platform and push it against the geospatial data that you find valuable. And I can't emphasize enough the power that it's just SQL. It's a matter of getting into the platform, getting into the IDE online, and simply writing the queries that you need against the data. And because of the power of BigQuery's scale-out architecture, you have the ability to get answers in seconds that used to take hours and days. We've also extended BigQuery with a number of partner rendering and analysis options so that you can bring the tool set that you need to bear against the problems that you need to solve, whether you're a data scientist or a SQL analyst. One of the other great things that we've done is we've extended BigQuery and the ability to then take that data that's hosted in BigQuery and use it to render the BigQuery data onto Google Maps in partnership with CARTO. The second big thing that we're announcing, that we've recently announced, is a private preview of Google Earth Engine. Google Earth Engine is a planetary scale platform for Earth science data and analysis. We're taking advantage of the enormous explosion of satellite data that's become available over the last several years. And we're building a platform that takes into account both that enormous catalog and the necessary computation in a cloud native manner to take and get value out of that data. So what's Earth Engine? First, it's that set of comprehensive analysis ready data assets co-located with the necessary processing and computation power to allow you to truly unlock the value, all powered by a simple API and available via a browser-based IDE. There's no software that you have to download. There are no systems that you have to go install. You can do it all sitting directly in the platform. And when we talk about the data that's there, we're talking about more than 50 petabytes of data that's growing at more than a petabyte a month and currently constitutes more than 700 data sets. This is an example of that browser-based IDE. You have complete access to the environment, to the data that you can see, the ability to sit and write the code there and see the results in the browser. We take it one step further. So we've talked about the computation, we've talked about the availability of that data, the ability to analyze that data, but now we also have the ability to bring to power Google's expertise with artificial intelligence. A great example here is, again, getting into that IDE and using the power of AI to recognize things like cloud cover and go through multiple data sets in order to filter out that cloud cover and carry it out of the images so you get a composite image that matters. So what does this all look like when it comes together? Well, first, you look at the enormous amounts of data brought together in over 3 million Landsat images here for this analysis that the Times did. Over 1,800 terapixels of data, 1,200 years of compute time 10,000 CPUs brought together in parallel on Earth Engine, delivering a result in 7 days. This is the power of bringing together the data, the network that can ingest all of that data, the compute capacity to analyze it in a scale-out fashion, the analysis tools that can give you an answer back in the time and responsiveness that's necessary in order to get answers we were never able to get before. Those data assets, well, geospatial data assets in the marketplace, ready to go. As well as the best of Google. Maps resources, Waze resources, as well as visualization capabilities, and Google Cloud there to help you with the analysis. Not just the best of Google, but the best of Google and our partners. Partners that have chosen Google as the best platform for their geospatial workloads. Partners that are enriching the geospatial workloads of their customers and the ability to analyze and visualize all of it on Google Cloud. So with that, I'd like to say thank you for your time. Have a fantastic day.
Awesome. Thank you for that great talk, Bryan. It was great to kind of get a more holistic picture of all of the infrastructure that goes into everything and then all of the cool things you're doing because of that infrastructure at Google today. So appreciate your time. We do have a couple of questions for you in the Q&A here, if you're ready then. Are you seeing questions about location intelligence or geospatial coming up in your executive conversations versus just with technical leads?
Yeah, consistently. Part of that is because a lot of the executives are struggling. A lot of the businesses are struggling with getting a better understanding of the world around them, how it impacts things like their sustainability goals, or even just their relationships with things like their vendors, their suppliers, their own supply chain. And so there's a challenge there of how do they get the data? How do they drive that data to insight? Where do they find the talent that can actually go and make that connection of data to insight? The other conversation that's coming up pretty consistently is what I'll call, the data that they have is sitting around them that they may be able to make use of, and it's not their core skill set. They don't really understand or have the pipelines to be able to take data that could be very valuable to themselves, to their partners, or to just other interested parties around them, and to make that available to the broader community at large. So you're kind of seeing both of those conversations. And I'll add, when you look at the industry, a lot of times this data is there, but it's been made available and sold to them for their use. They own it, they own the platforms, or they own the systems that are generating it, but they don't have the skill set or the capability to turn around and then make that available to other parties that might be interested. So there's a lot of conversation in the executive spaces along those lines.
Gotcha. That's great to hear, especially around sustainability efforts. I know Google is doing a lot in that realm of things, and you're working with a lot of great partners there. Just out of curiosity, going off of that point, has there been increased interest just in the past year and a half based on sustainability, and what type of data are you seeing people use for these initiatives?
Yeah, definitely a lot of interest in sustainability, a lot of interest in kind of pending regulatory changes where folks where it's no longer just motivated by a desire to improve the sustainability. Also motivated by customer and consumer interest in more sustainable goods that can legitimately make that claim, seeing the kind of the business value start to come out of it. So absolutely looking at these data types to be able to start answering the sustainability story. And so that's where you can look at Google, and you can look at the different partners that we're bringing along to start answering some of those questions. And we've made some kind of interesting announcements here in the last week or so around how we're helping folks answer some of those sustainability questions with folks like CARTO.
Absolutely. Happy and proud to be a part of those initiatives. Another question we have here, Or what are some of the biggest barriers to democratizing geospatial today?
I think I alluded to a couple of them. Like the obvious one is cost. This is a very rich data set, but it's not necessarily without its cost barriers to turning around and making use of it. And so this is one of those things where cost inhibits democratization, but democratization can help us reduce cost. And so getting in and getting this valuable to more people and getting it onto platforms that are easier to use would be one of those kind of critical elements that we see to making it more usable. So there's the cost, there's the technical barriers, there's the skill sets necessary. If you're asking and answering a question yourself for the first time, you have to drive that entire kind of insight chain where you're going from the raw data all the way down to actually answering the question. There just isn't a whole lot there of just being able to kind of query and say, hey, where can I go get this information? So there's the cost of the data itself, there's the cost of the talent and the limited access to the talent, and then there's the barriers of platforms, right? You've got a whole bunch of different platforms and a whole bunch of different disintegrated data sets and marketplaces that really, bringing them together in something like Earth Engine and, cloud for geospatial, making these things available as plugins to systems like BigQuery is really trying to make it possible to come into a limited number of places and get access to all of the different data types that would be available and of value in helping you to answer those kind of questions.
Absolutely. Yeah, kind of a catch-22 with the cost. It's like, well, it's too expensive to do. It's like, well, no, wait, it will actually save you a lot of money in the long run. So
yeah,
understand you there. We have another question saying, I wonder if for non-entity tied individuals or free users, could they leverage and enjoy all of these resources?
Yeah, you have access to the platform where you have the ability to get and use the existing data sets that are there. This walk up with your credit card and you have the opportunity to be able to take advantage of the full power of the platform. It's not restricted to specific relationships or contractual relationships.
Awesome.
Yeah, the other part that I'll point out, BigQuery actually has a free tier. So you have, if you stay within the free data sets and you've got a certain set of queries. I think it's well, I'm not gonna try to go from memory on what it is, but if you Google BigQuery free tier, you'll have the ability to kind of get in and see the number of queries that you're able to run without having to pay.
Perfect. We have another question, kind of going back to the last one. So some of the cost barriers and talent barriers are things that you mentioned. And some feel that most players in the geo industry need to communicate better as well to solve some of these issues. The industry needs to stop categorizing itself into boxes. As in, to become part of the mainstream, it needs to speak the mainstream language, to truly break out into the world of logistics, health, epidemics, agriculture. It needs to explain the value of where and why. Do you agree with this? And or what other solutions would you propose to reach these users that there's a cost barrier, the communication barrier, and things like that?
Yeah, like I think that there's a lot of truth there. One would be not just speaking kind of a common language. I mean, we could talk about technically the thing that like excites me the most about things like integration with BigQuery is it's just SQL, right? So there's that nerd language barrier. But the other part is if you're communicating to the executives, we've got to be communicating not just in the value of where, but we've got to be talking about how we're unlocking their ability to answer the strategic business challenges that they need. Sustainability is a great challenger. Everybody's still trying to kind of grok exactly how impactful that's going to be on the business. I love that we're getting to a place where we're actually talking about the long-term business value of sustainability efforts, but getting the conversation to that level, getting the conversation to the point where it unlocks and answers the strategic business opportunity and the value in the business by And by the way, not just the value to the end business, but the value to the entire supply chain of being able to go in and drive value back to, call it, raw materials producers that sometimes may get squeezed out by all of the middlemen in the supply chain. The ability of kind of driving that value all the way back through the entire supply chain is something that absolutely we've got to communicate better. The other part here, or another example that comes up, is in the consumer branding space, where you can legitimately claim and transparently prove that you are more sustainable, right? So it's not just the value to the business, it's not just meeting regulatory requirements, but it's also proving that in a transparent way back to the consumer. That's another language barrier that has to be overcome, because the consumer that's out there buying their shampoo or buying their product, like the label or the sticker on the bottle is only so meaningful, but they may not be able to take it back through and actually understand some of the demos that we tend to share in conferences like this. The other part that I'll say is, I love the point about categorizing itself into boxes. These problems inherently break any kind of barrier between data types. And so one of the challenges is actually thinking about how do we bring together all of these different data types in order to be able to answer the problems that these businesses are actually facing. I think this is a space where we can start breaking it down by getting into tools like BigQuery and Earth Engine and getting the different plugins. But we've actually got to go beyond that and get to the point that all of the different data types can be brought together very easily and to give a kind of a seamless analysis.
Absolutely. And you made a great point earlier that a lot of people don't even know they're sitting on a lot of this data that can be used for location analyses. And then they also don't know that they can bring that all together with data that might be available in BigQuery natively and things like that. So I think that is all the time we have for questions today. But thank you again so much, Bryan.